Image formation rules for lenses. Before we proceed with this section, let us see what we mean by the terms a convergent lens and a divergent lens. In the case of a convex lens, if the rays coming from the object are parallel to each other, then after passing through a convex lens, they will converge at a point known as the focal point of that lens on the other side. That is why we call a convex lens a convergent lens. It stands to reason that since the rays are actually meeting at a real point in space, the image formed at that point will obviously be a real image. On the other hand, parallel rays coming from an object after encountering a concave lens will diverge away from each other. In other words, once these rays have passed through the lens, they will never meet again. In this case, we can produce the path of these rays backwards and locate an imaginary point behind the lens where these rays seem to be originating from. Thus, the image formed by this divergent lens, this concave lens, will be virtual. Now, having said that, let's look at the rules for rays in these lenses. Rays traveling parallel to the principal axis in a lens pass through a real or imaginary focus. A real focus in the case of a convex lens and an imaginary focus in the case of a concave lens. Next, rays traveling through the real or imaginary focus, depending on whether it is a convex lens or a concave lens respectively, will travel parallel to the principal axis after refraction through the lens. Next, rays traveling through the center of curvature, whether it is that of a convex lens or a concave lens, will suffer no deviation, no bending and no distortion as they pass through the lens. They will pass perfectly straight. When the incident rays are parallel to each other, or in other words, the object is at infinity, the rays will pass through a real or imaginary focus, which means that the image of any object placed at infinity from the lens will be formed either at the real focus for a convex lens or the imaginary focus for a concave lens. When the rays originate from the real or imaginary focus, depending on whether the lens is convex or concave respectively, the image is formed at infinity. Next, the sign convention for spherical lenses. Just like mirrors, we use a convention for lenses. These conventions are identical except that lenses use the geometric center of the material as the reference point. So again, all distances measured to the right of the pole, or in this case the center of this lens, are considered positive, and conversely all distances measured to the left of the center are considered negative. All distances measured above this center are positive, while the distances below the center are considered negative.